generic. Okay, what do I mean by generic? They're not something specific to Java, right? Just because I discussed all those data structures in core Java class does not mean they are part of Java or something like that. Data structures is same for everything. Okay, because data is printed, there is not much last in first out format. Okay, so that is generic for every programming language, not just Java. You do the same thing in C, you do the same thing in C++, in Java, and all programming languages. Okay, so the structures until this point is just an idea. Okay, so if you want something to be stored in LIFO fashion, then it's a good idea to use a stack. Now, the implementation part is dependent on you. Right? For example, if this is an interview and if I ask you to solve a question and I'm giving you a hint, you know what, this question can be answered. Just a minute. Hi, Akab, is this lecture entire unit of structures? No, this class or this session or this lecture is particularly about collection framework, which is still part of core Java. But I was talking about the lecture on Saturday. That is going to be about data structures. So again, just answering your question. So coming back to the data structures are just generic. Okay. So yeah, I was talking about that thing, right? So if I have a question for you guys as an interview, then just to give you a hint, I'll say, you know what, this question can be solved in stack. Okay. So here you only understand that the question can be solved in stack, but you can implement it in Java, C, C++, doesn't matter. But the only thing you have to make sure is data should be in the LIFO fashion, last in, first out. You can implement it in any programming language that you're comfortable with. That is one reason why interviewers always go with data structures. They can test your thought process and all, and also there is no restriction on programming language, right? It's up to you, and they'll actually ask you to pick your own language. They won't ask you to solve a problem in C, solve a problem in Python or something like that, unless you're applying for a program, platform specific position. They keep the options open. So that is one advantage why they test you more on data structures, because it's just idea, right? Because when you say that you can use stack for this, that only means that you want LIFO nature. So you can do it in C, C++, Java, and everything. So we're not concerned about C, C++, Java. We are only concerned about data structures in Java, right? We should implement data structures in Java. And see, this is how data structures are actually implemented. Okay, see, again, this is not Java, don't get confused with C++, but I'm just giving you an idea. Heap, I don't know if you're not familiar with heap. Heap is also data structure, but let me just, we don't have any program here. Okay, yeah, I got binary tree. So this is a binary tree program in C++. So insert operation in a binary tree. How do you insert an element in a binary tree? This is the function, how you insert an element into a binary tree. How do you print the nodes of a binary tree? This is one function. So this is how you implement a data structure. You write your own functions. So through this, for example, if this was an insert function for stack, right? So you have to make sure that each element will be on top of the previous element, right? So you have to make sure, again, this insert function doesn't matter if it's implemented in C, C++, Java, but all you have to make sure is this insert function will insert value in a particular way that stack is required to, right? So this kind of code can also be written in Java, which I'll talk about on Saturday, how to actually write, manually write functions for data structures. But collections is a framework which makes this kind of stuff easy. What do I mean by this kind of stuff? What I mean is all the data, exactly, some of the data structures, not all the data structures, but some of the data structures that you need are predefined for you in this collection framework. So now you understand the collection framework is a set of classes and algorithms readily available for you. So if you need a linked list, you don't have to actually go implement linked list, something like this. You can directly say, I want a linked list, and you want to insert an element just in one line. You don't have to go ahead. See, for example, I want to insert an element into a binary tree, right? So in C++, we don't exactly have framework like those. That is why Java is preferable, because you have collections framework in Java. When you need data structures to store items, you can definitely use collections framework, predefined classes. But if you're a C++ programmer, you don't have that kind of framework. So for example, do you see here I inserted some elements into a tree? Although it looks simple that I just wrote insert of 1, insert of 2, insert of 3. But I should actually provide the implementation of insert method, right? And in this implementation, because it's a C++, I've done it in C++. This is how it's done. So this is nothing but the method for insert. Okay. But whereas in collections framework, you don't have to actually implement your own methods, is what I mean. You can just directly write, I need a queue or I need a binary tree, start inserting elements into binary tree. You don't have to write your own implementations. That's the point of using any framework. That is what I told you with the Hibernate framework, right? Even if you didn't understand what JDBC and how to connect your Java program to database with JDBC, you always have advanced frameworks, which is nothing but again, it's Hibernate is one such framework which deals, with all the lower details that you have to do in JDBC. Takes care of all those details. Hibernate will just ask you to provide some simple details and it will give you the connection. You don't have to, explicitly write all those things. That is what every framework does. So specifically here, collection framework will provide you certain classes, methods, and interfaces which you can use to directly start using data structures directly. You don't have to implement the methods. Okay, as you can see, it contains interfaces. Implementations, nothing but the classes that implement this interface and algorithms. So let's just see how the entire hierarchy. This is the entire hierarchy of the collections framework. You have to be familiar with this framework. I don't know if you by heart it or if you learn it. You have to remember this thing, this entire thing. And there's one more interface here, although it's not here. Imagine there's one more interface next to set, okay, called as map interface. Again, don't get confused. Just imagine, but it's not a part of collections entirely. Okay, although it's considered among collections, but it was later on introduced in collections. Okay, so imagine there's one more interface map, which we'll talk about by the end of the class. So the four main interfaces that you have to that we deal with collections is list, queue, set, and the other one is map interface. So these are the four interfaces that we'll look in this class specifically today. Okay. Now all these four interfaces implement another interface called collection, which is a super class of what? Iterable. All these green things are nothing but the interfaces, and all the purple, I don't know what is that purple kind of things are nothing but the classes. So these are the classes under this interface. These are the classes under these interfaces. And these are the classes under set interface. And there are three more classes under map interface. Same thing. Hash map, linked hash map, tree map. Instead of set, you just replace it with map. Now, so we'll see, before talking about collections, I just want to make one thing clear. So there are different collections. This is one collection, and this is a different thing. This is a different thing. Collections. Yeah. So collections is different. Collection has a different meaning, and this collection has a different meaning. Although, do you see the differences between these three words? This is collections. Okay. The collections is actually a class. Okay. It has some methods defined, like sort method and all those. We'll use those methods today in the class. But this is a class. Collections is a class, and collection is an interface. Right? Collection is an interface under which all the list, map, not map, all the list, set, queue, everything comes under. So collection is an interface, and this collection, which is nothing but C. If someone says use a collection, they'll just write like this. So this is not a keyword or something. It just is an English word which means a group of objects. Right? So for example, when someone says, hey, you know what, this problem can be solved by using a collection. So that means they are referring this word. Okay, so this problem can be solved by using any collection. That means you can use any collection. These are all collections. Array, list, linked list, vector, stack, all the collections. Okay, so you have to really understand what the difference between these three things, and finally you have the collection framework itself. Right? Collection framework, it has all these things, collection, and all these different classes. This entire thing is itself the collections framework, which has interfaces, these classes, and some algorithms. This is nothing but the methods, which I'll show you a couple of them. But that entire thing, classes, interface, and methods, three things commonly called as collection framework. So now just go ahead and see the array list class under the list interface. Let's go ahead and create a sample class. Just take a like example. Awesome. So what I'll do is I want to create an instance of array list. First of all, why do you use collections? What's the use of collection? As I've told you, it's nothing but it's a data structure, right? I mean, all these things, array list, linked list, queue, priority queue, these are all nothing but data structures. So now the question is, why do you use data structures? To store something, to store certain objects, right? To store something, because the limitation with data type was you can only store one thing, right? If you have an integer, then you can only store one integer. If you have a string, that can only store one string. So what if you want to store 100 strings in one object which is related to each other? What do you want to do? So in that case, you want a bigger data type, which is nothing but bigger data structure. So you use data structure to store multiple objects. So now let's use an array list AL. Suppose since array list is a class, you have to create an instance of the class. There is nothing but all the collections, everything, all classes and all are included in this package java.util. So make sure when you write array list, make sure you import the package. Again, the shortcut is Control plus Shift plus O, right? So I've got an instance of array list. Now, all I have to do is, if I want to insert elements into this, all I have to do is use that object itself and then call the methods of the array list. I think it's slow. Yeah, sorry. So do you see all these methods? These are all predefined methods for that particular array list. So I just want to add something to it, right? So let's just call add and then say hello. And let's add one more thing. I think it's enough. So that is all. Now you have stored certain objects into an array list. Now let's just print the array list. See what happens now. No. No, you can have anything inside there. I don't know why this word always pops up. Or let's just say 5. You can store anything. So it's just like a container. It stores anything. So see, I have actually created an array here and then inserted elements and then printed it. If this would have been a binary tree, it would have been same thing. Just create an instance of a tree, keep adding elements into it. Now you see the actual C++ code here. I'm showing you this thing because collections framework, this frameworks actually make our lives easier, right? So here you have just for adding, inserting things. So this is the size of insert function. This is how it actually somewhere between 20 and 30 lines just to insert an element into a binary tree. But when you use frameworks, all you have to do is just call predefined methods and those implementations will take care of it. You don't have to write anything, right? You just use predefined classes methods and put those elements together. That's it. Now, one thing I want to show here is how many ways you can print the contents of any collection, because that's really important. There are many potential interview questions there. So let's list it out how many different ways we can print the contents of array list. Okay. Now, one thing you have to know about the list array list is it implements list interface, right? So one thing about list interface is it accepts duplicate values. Even if you have multiple duplicate values, that means even if I have string Java 5 times, then it will print Java 5 times. Why am I saying that is because classes that implement set interface does not do that. They don't print or they don't accept duplicate values. Even if you have 5 strings as Java, then only one string of Java will be stored and only one string of Java will be printed when you actually print it. So that is the difference between list and set interface. List accepts duplicates, set does not accept duplicates. Let's see how many different ways we can actually print contents of array list. Again, array list, the behind the scene implementation is nothing but it uses a dynamic array. Okay, so you know what an array is, right? Contiguous memory allocation. So it stores each object next to each other, and so you can ask the question where we are actually initializing the array. We need to initialize the array, right? Because it's a fixed size memory. You have to say that I want to create an array of size 10 or size of 20, but you don't see that anywhere here. So what's exactly happening? The thing is, if you remember, I've told you there are alternatives of array they came up with, which are still not efficient, but there are some alternatives of array. So this array list is also implemented by an array, but it's a special type of array called as dynamic array. What happens is once your array is full, because array is fixed size memory, right? So you can only have, for example, if you are declaring an array of integer, like of 10 integers, right? So initially we only have 10 integer memory spaces reserved for you, and once you store 10 integers, you cannot store 11th integer. That is the case with the normal array. But if you have a dynamic array, what happens is when you try to insert 11th element, the array itself extends the space to 5 or 10 spaces. That is what increases its size by 50% or 100%. Again, that depends on the implementation itself, but I think array list extends it by 50%. So you don't have to worry about providing the size. So it just keeps on increasing. So you can provide as much data to be stored in the array list. So let's see, again, coming back to the thing where I wanted to show you how many different ways we can use print an array list content, right? So this is just one way, printing through the system print a line directly to the object. And then let's use for each loop or for loop. Let's initialize the number and then say I is less than the size of array list and keep on incrementing. Then since it's an array, I can always access contents of array through index, right? Because array has random access in it. So what we'll do is I'll write al dot get index I. Right? Do you understand how this for loop works? First, I'm initializing I with 0. So in the first iteration, the I will be 0. So I'm getting value present at the 0th index. And for each iteration, I value is incrementing. So I'm getting index 1, 2, 3 until the size of the array list. That's what I'm doing. Let's see if this works. Works, right? Awesome. So this is one way of doing it, and then you have a loop called as for each loop, which is actually introduced in Java 7, I think JDK 7. They came up with a simpler version of for loop, which is only used again for read-only purposes. You cannot edit something. For example, this for loop can be used to write something into array list also, right? But this for loop cannot be used for writing purposes. It's just specifically designed for only read-only purposes. I'll tell you why, because let me write that for each loop. for each object O present in array list, I want to print O. So which for loop is easier, this one or this one? Obviously this one, right? I'll explain what I did, what the for brackets and all those things have inside. Let me run the code. It works. It works, right? So the reason we call this as for each loop is the way you actually read it. The way you read it, for each object O present in array list, keep printing the object O. That is how you read it. So every loop, in every iteration, one of the objects of array list will be stored in O, and you're printing it O. So the way you read it, the way you read this is for every object O in the array list, you keep printing O. Again, what is this object? Can I write string here? I can write a string here. You can write any data type that you want and all the kind of thing. But the problem with that is all this collections by default, they store only objects. They don't store primitive data types. They don't store objects. They only store primitive data types. That's the reason. If I actually said this in the class, I don't know if you guys remember this, but I told you in collections there are certain methods or classes which only accept objects as parameters. So that's the reason we came up with something called as wrapper classes, right? So all these collections, they don't store primitive types. They don't store integers, floats, and all that kind of stuff. They only store objects. Now, seeing this, do you have a question about what I just said? I said array list cannot store primitive data types, only store objects. Then how is it storing this thing? Isn't that a primitive data type? It's an integer, right? Yeah. So what exactly is happening? What is this thing, auto boxing? Do you remember what auto boxing is? In the wrapper classes were discussed about it. Auto boxing is nothing but, and even if you pass a primitive data type or something, it is converted into its wrapper class equivalent, right? So even if I'm passing 5 as a primitive data type, this is implicitly converted into an object of integer, object of type integer. That is what is being done. So this is called as auto boxing. It's really important, guys. Make sure you remember this thing. So whenever you're passing all the primitive types, right? All characters or integers or float, they seem like you are passing primitive types, but it implicitly converts them into equivalent objects and then store them as an object. So this 5 is not a primitive type here. 5 is an object of type integer. That is what it is. So that's the reason, because all these are objects. Instead, if I write string here, then this is not string. So if I write integer here, I cannot read these values. So I just want to be vague. I don't want to be specific. So that's the reason I just said for each object, and it's actually a class object. So you need not worry about that. We never used it, but still object is a class in Java lang package. So if you want to refer to any random object, string, integer, you're not sure, you can just go ahead and use object. So for each object, if there were only strings in here, you can always write for each string in array list or something like that. Okay, don't worry about that. Any questions about this for each loop? Questions? Awesome. Now, there's something called for each method. I think that's for each method. Let's try. Is the array list object al dot for each? Yeah, there is for each and system println. System dot out Oh, I think, yeah, that's, yep. So this is one way of printing this for each method. So there is a method called for each, right? So basically what you're saying is for each object of array list, do this thing. What we're doing, printing. So this is one way of doing it. And what else? Yeah, we can use iterators. Let's use iterators. I'll tell you what iterator is. Iterator, builder, iterator. You have to import the class iterator. Java util iterator. Awesome. And then iterator is nothing but just like we have result set in JDBC, right? We have result set which keeps on going, which is like a pointer which keeps on pointing to the next object and keep printing it. That's the same thing here. The iterator is nothing like, it's like a cursor. Okay. So it initially points to the first object, that is nothing but hello, and then you keep on moving it until the array list is empty. So the way you write is while iterator has a next element to print, keep printing the iterator cells. That is what you do. While it has a next element to print, keep printing the next element is what you're saying. Let's say if this works. Iterator, it goes right. So again, iterator is what you have to do is it's just a method iterator which is defined for this particular collection. So when you call this iterator, it will return you an object of type iterator. So you're storing that in ITR and then basically using that you're saying until you have a next element to print, keep on printing the next element. So you also have something called as list iterator. Let's see that one. List iterator, the way iterator ITR2 is equal to AL list iterator. Import the class list iterator and then write while iterator 2 has next. Same thing, but just a different class. Print iterator 2 dot next. List iterator. It works, right? So that was the difference between iterator and list iterator. List iterator can iterate both ways, forward and backward. Okay. So this is forward, right? Because it's printing one element after another. Let's go in reverse direction. Let's do one thing. Okay. Let's run copy this. I need to copy blue and just say iterator has until iterator 2 has previous, keep printing the previous element. I'm sorry. Backward. Right, it printed it. Let me just make it a little more clear. This is the normal iterator. It's printing it in forward direction using next method, right? So hello world 5 Java, and then this is using previous method Java 5 world hello. So the way it works is, the one question, can I call previous before the forward direction? Can I do this thing before this while loop? I cannot do that because I said iterator works as a pointer. Okay, so let's see what happens if I directly call this. Let's see if that works or not. Right? It didn't print anything. Are you trying to first put it backward and then? Yeah, I'm trying to first print backward and then forward. It didn't print anything because not there exactly. I'll explain. So now here I got the initial status where we are just first printing forward direction and then backward direction. I'll run the output again. And now it's working. Right now in the backward we are first printing Java and then 5 and then 1. So the reason is, I said your list iterator works like a cursor. So initially it points here. So when you're saying has until this cursor has next, keep on printing next. So it goes on to the next element and then cursor is here. Right? So when you're calling iterator 2 as previous, so already the cursor is here. So there is a previous element here, right? So that's the reason it works here. But when you first call previous backward, that means by default the cursor will be here, right? So it doesn't have any previous element to go. That's the reason it didn't print when you first call previous. That is obvious. Any questions about this? Guys, any questions about this? Different ways of printing RLS content? No questions? Awesome. So these are different ways of printing the contents of RLS. Now the question is, why did I spend so much time here just to display 5 different methods of printing array list? We have these many classes to finish. The thing is, it all works the same: array list, linked list, vector. There are slight different implementations. In linked list, this thing shouldn't work. Hopefully, let's see what happens. I'll remove array list, and I want to have a linked list here. Let's import the package and see linked list. Everything works fine. Let's run the program and see. Yeah, linked list. Anyways, because it's a linked list, you cannot access elements through index. So this thing shouldn't have worked, but I don't know how it's working. Anyways, so the only difference between array list and linked list is implementation. Rest of all, you can see you don't have to change any class of methods, right? So the behind the scene implementation is different for these two classes. Array list uses dynamic arrays and linked list uses doubly linked list to store elements. That's the reason you don't have to change anything else. Let's try with the other class. So the other class is vector, right? Awesome. Let's see. Vector. Let's try this one. When this one works, yep. So all these classes are same, but stack again, it's a legacy. Stack and vector are actually legacy classes. What do you mean by that? What is a legacy class? Legacy classes, this collection framework was introduced in Java around 1.4 or 1.2, some number. The point I want to make is it was not in all the versions of Java. It was not right from the beginning. So back then, how did they used to solve them if we didn't have a framework? did they used to implement the actual logic? Well, they used to, but still they had some predefined classes to also do that. So some of those classes are vector, stack, and you have priorities and a couple of dictionary and a couple of other classes. So those classes used to provide certain predefined implementation for data structures like this now, but later on, after second or fourth version, they introduced an entire framework called collection framework. So because this is new, these classes are called as legacy classes. Okay. Yeah, they still use. But one really important question here is they just not tired of asking is difference between array list and vector, because vector also uses dynamic array, array list also uses dynamic array. So is there a difference between array list and vector, or when do you decide to use an array list or vector? Yeah, any questions?
Vector is asynchronized, right?
Exactly, yeah. So there are a couple of other differences apart from that, but what she said is array list is not synchronized, vector is synchronized, and we all know, I said that whenever something is synchronized, it just slows down the process. So since vector is synchronized, insertions and deletions are relatively slower, but whereas array list, it's kind of faster because it's not synchronized. And there are a couple of other differences. And for collections especially, I actually suggest you to go ahead and try Java T-point. I actually told you, right, about the Java T-point. In Java T-point specifically, look for collections. This actually has pretty much everything what you need. See, this is the framework, and you have all the things that you need here. So I was talking about array list versus vector. There's array list versus vector here. The array list is not synchronized, vector is synchronized. I said, right, array list actually increments 50% and some increments 100%. These are the differences. Again, this is really important, so you might just have a look at it later. But yeah, the theory behind these classes is really important. Like for example, they can ask you what interfaces can link, what interfaces does reset implement, right? Then you should be able to say that reset implements this interface, and you can only say those kind of questions when you have a picture of how collections framework look like, because it's really important. I'll tell you why it's actually important. But there's something called as map interface, which is really useful if you're applying for, if you're expecting questions on data structures, especially in Java. You can just solve many questions just using map methods. You have direct methods, right? So yeah, array list, linked list, vector, and replaced all the three instances with each other. The code works fine. So the only difference is what kind of implementation they actually use. This uses doubly linked, the doubly dynamic array, and linked list uses doubly linked list. Vector still uses dynamic array, but it increases by 100%. The full length of itself is being replicated each time in stack. And one more thing, even I said this thing also during inheritance and composition, right? Like when do you prefer inheritance and when do you prefer composition? And is it really important to have that kind of difference? Both kind of do the same thing, right? Subclass will eventually have the access to superclasses, right? So what's the point in having inheritance and composition? See here, stack actually extends vector. Okay, that is how it is in Java collections framework. You see, right? There's an arrow mark here. Stack extends vector. Go see the definition and documentation. It's that way. Stack extends vector. I'll tell you, that is actually considered as the blunder in Java. There is one blunder there. I don't know, was intentional or unintentional. The reason is because vector, linked list, array list, all these are lists. In vector, what happens is because vector is implemented using a dynamic array, you can random access vector, right? So that means you can take out an element from the middle of the vector. But can you do that for a stack? You cannot. Stack can only be elements can only be removed from the top, right? Push and pop functions for stack. So you can only insert and remove elements from top of the stack. So that means stack is a vector, which it is not. It's not. Stack is not a vector because you cannot remove elements randomly. So instead it should have been composition here. Vector has stack or stack has vector, it would have made much more sense than just directly having inheritance in here. So that is a reason why, you have to give a thought before directly inheriting classes. You have to think of other options as well, composing and all of that. So those were about the 4 different classes, and go try all of this. Again, I've shown these things, but you have to try the Q interface. I'm not going to show that same. There is no absolute difference. How you have the same methods, add, and all that kind of methods, but just write the code. Okay, I'll tell what set and mass are. Those are really important, but Q you have to do. And one more thing about array list and all that is there are many other methods which we can use. For example, if you have another, let's bring it back to array list. What does the word legacy? Legacy classes is just old classes. It's just a identifier. So what I'll do is I want to have one more array list, AL2, right? And then I want AL. Let's have the same thing. So now you have 2 array lists which have different objects, right? So you always have methods like AL dot add all, so you can directly add in another collection to existing collection. So you just press array list 2. Now you try printing. So you already have this method, right? So let's see what happens. So first you're printing for AL2? No. No. I'm just printing array list AL, but what I'm doing is I have another array list. I'm adding the contents of array list to this array list through this method. Again, you have, you have, what's that? Hello world for Java, hello world 196, Java Score, everything has, yeah. Again, you have different methods here, not just add also. Try different methods here. Way too many methods to talk about in this class. You have something, one important and another is remove all. Remove all. Yeah, you have remove all. So once you have added, if you want to delete it, you can remove and retain, replace, just keep trying different methods. Now the question is, fine, we have stored certain objects in array list, linked list, vector, and all these classes. But all these objects were predefined, right? Strings, these are all not user-defined objects, right? But can we define user-defined? Can we actually store user-defined objects? What is a user-defined object? The classes that we create and the objects we make, right? For example, see, hello is a string, but I said you string is a class. So whatever, this instance is nothing but an object, right? We spoke how these objects are being stored in string pool, in heap, and all that thing. So the hello world, five, Java, all this, everything that array list is storing is basically all the objects. Strings are objects, even the data types are being converted into integer type objects, everything is objects. So now, can we store user-defined objects also? For example, what I'll do is I'll have a class student, okay, and then I'll have something inside the two variables or something. Now if I make objects of class student, so those are nothing but user-defined objects, right? Because that is a class I created, whereas string is a class that is predefined. So when I create objects of string, those are not user-defined, those are predefined objects. But here I'm writing my own class student and I want to create objects. Can I store those objects? Let's see if I can or cannot. Let's write a class student and just put some name, that's fine. And you can also have ID and then write a constructor which initially does nothing, and then a parameterized constructor which takes string and name as input, and then pass name to it, and then ID. That is it. Now I have a class. Now let's create 2 or 3 objects of our class. So student is equal to new student. Let's just say check and then ID 4569. Let's create one more object of student and then one more. S2, S1. I don't know if that's the name or not. 85, 88, fine. No. Comment everything. Don't want these many printf statements. So just commenting. Yeah. I don't want these things. I'll just remove this stuff. And I created 3 objects of my class student. So now S, S1, S2 are user defined objects. And I want to store these objects. And this is what you actually do in real time or in your program. You never use RLS to, I mean, you use, but then mostly you want to create your own objects. And if you want a place where you need to store all those objects together, so you use RLS and all those kind of classes to store these user defined objects. Now I have an RLS class. So what I do the same thing, AL.add, and then what is the parameter of it just takes object, right? So instead of passing directly string, what I'll do is I'll just pass S, just like that. Let's add the rest of the 2 as well. S2, S1. Let's see if this works. What do you think the output will be? What happened here? Exactly, that's hash code. I we talked about it. You are directly trying to print an object. It will print back. This is the package name. This is the class name student, and this is the hash code of object S1, which is nothing but a unique ID that JVM assigns to it. So now what we have to do, if you want to actually print something, then you have to, when you want to print the object of this class, and you don't want a weird hash code to be printed, and if you want something meaningful, a text representation to be printed, then you override a method called as toString. Just right click and go to source and click override, and then you have toString, override that method. So you just want to print name, return name plus ID. That's fine. That is all I want to print. Let's see what happens now.
If we just return S,
Here, yeah, that is a class. You cannot do that. Class won't know what SS1, S2 is, right? It's just a class. Here it should all be generic. You cannot go specific. You cannot return objects. This is a class. So now when I'm trying to print, it printed all the 3 objects, right? So these were the objects that we're trying to store. So this is one way of telling that all the collections also store user-defined objects. Now let's go to the, again guys, you have to do the queue interface thing. Priority queue, array DQ, these are just 2 different classes. There are only 2 classes in queue interface. This class priority queue implements queue interface, whereas array DQ implements both the things, both the interfaces. Now, the priority queue is a queue which does not follow FIFO order, first in, first out. It does not follow that order. It follows what the it outputs elements based upon the priority. So there's something that has high priority, it will first spit that out. It does not really follow first in, first out. So is it really used? Then it is. There's something called as OS scheduler, right? Operating system will be waiting for processes, right? So those processes is nothing but priority queue. So all the processes that need CPU will be put into the priority queue, and the process with the highest priority will be going into the CPU to get executed, and then it will go back to the our secondary memory. That is nothing but our hard disk. That is how it works, right? So you have just same, just like we did array list, linked list, you can implement these two classes, try different functions, try different methods, add all and all those kind of methods, try printing them as well. Okay. Now we'll see the set interface. There are three classes in set interface as well: hash set, linked hash set, and tree set. First thing you have to know is hash set class is it uses a hash table to store elements. Right? Now, what is a hash table? Hash table is also a data structure, which we haven't actually spoken about, but it's kind of a big deal, to be honest. It is really important, and I actually said that right in the last class. Most of the questions can be answered with hash table or something. That is what it is. The hash table is nothing but it takes the advantages of both array list and linked list. What is the advantage of array list? Random access. What is the advantage of linked list? Dynamic size. So it takes both those advantages, and developers have actually come up with a new data structure called as hash table. So how data is stored in hash table is it's basically an array, but you can also simulate it like a linked list. So when you try to insert something into hash table, it performs an operation on that input, and based upon some calculation, they put it in a specified location. They don't just take your element and throw randomly in array. They perform some kind of calculation. That calculation is nothing but hash function. It's called as hashing mechanism. So whatever input you give, it first hashes it and then stores it into the hash table. So whenever you are looking, and then later on when you want to search for a particular element, you again pass it to hash function. It will run the same function on it, and it will again generate the same address. So it will directly go to that address, give you back. So it does not have to go and search through all the items just like you have to do it in linked list. In linked list, you have to ask each node, right? Where is the next node? Where is the next node? Where is the next node? So here you don't have to do that. Again, it kind of looks like confusing when I'm just speaking about it theoretically, but if time permits, I know it's not required for you guys, but if time permits, I'll definitely show you at least, a pseudo functioning of what hash table and hashing mechanism is. And I think there is actually a good video also which I'll include on YouTube. It's just a 5-minute video on YouTube, which she actually explains briefly about what hash table is. So I'll just right away forward that video as well. So that should explain what hash table is. But the entire discussion was just to let you know that hash set uses hash table to store elements, and linked hash set, same thing, it uses linked list and combination. Tree set uses a red black tree. So that's the reason, you know what a red black tree is? It stores elements in a sorted order. That's the reason it implements an extra interface called as sorted set. Okay, when you try and insert elements into a tree set, and when you print it, you can see that elements are in sorted order, in ascending order, right? So does this follow any order? Does this follow any sorting order? Linked hash set, it does. It's called as insertion order because it uses a linked hash set. The order in which you insert will be the order in which it will print. Again, all these things I'll show you by writing the program. Let's just go ahead and write the program. It will be more clear. Okay, let's take another class. Let's first write hash set h equal to new hash set, and then h dot add. I removed all those things here. Oh, I removed it, man. So anyways, let's just go ahead and create some object. And exactly. In some cases, if you want to store a certain kind of data, then storing in array list is not a good idea. Then you'll choose hash set to store because retrievals are faster. Okay, retrievals are actually faster in array, but then you have the limitation of fixed size. So it all depends. You have all these data structures. No matter I'm showing you what 10 or 11 classes here. Just remember one thing: all these classes are only used for one purpose, to store data. They don't have any other extraordinary use. just to store data. But why these many classes? Because they all store data in a different way. So it really depends upon your requirement, whether searching is important, whether you want something to be searched quickly, or whether you want a lot of storage space. It all depends on your requirement. Once you identify your requirements, then you can pick out your required class, and then you can go ahead with that class. Remember one thing, it's all used for just storage purposes. That is all it does. So hello world, Java, something like that. Okay. I've stored 4 objects in hasher, and now I'm trying to print the hasher itself. Hello. Right now, do you see, is there any order for that? The order in which I added and the order in which it came out. So this is called as memory order. This is just another name for randomness. Okay. This random order, it doesn't sort the objects that you store it. But whereas linked hasher, it will store, it will store the elements, or it will follow an order called as insertion order. Let me just replace H1. Linked hasher. No, let's run this thing. The output should follow insertion order. Let's just check hello lab Java word, right? The order in which you inserted the objects, the same order the elements are being printed, because it's a linked hasher, right? So one element will be linked to one other. So it will again follow the chain pattern. So you cannot randomly access it. Now we have the third class called the tree set. Now, it does follow ascending order. So you can see, right, H, I, J, K, L. It follows ascending order, right? That is what it does. So tree set follows ascending order. Yeah, yeah. Guys, I'll just be back in a minute. I think yeah, I think we have to go with some Unix, basic Unix stuff and SQL. Yeah, we'll have a class on Saturday anyway. So this thing on Saturday? Oh yeah, I'll do it. Yeah. You guys are fine here, right? So at 9:30, 10, 11, sorry, but okay. I don't think you require time, but still, I should finish it by 9:30. Anyways, sorry for the interruption. So we're done with tree sets, right? The tree set follows in a ascending, that is sorting order, ascending order. This follows insertion order, and hash set follows memory order. Just place it randomly. That does not literally place it randomly, but it computes that hash thing, and wherever it tells to place, it just goes and places it there.
When we call from headset, how it calls, because it doesn't know that, you just find the place and you place the location there.
No, there's something called as a hash function. Is there an apple in the hash table, or where is it? What you do is you again pass the apple input to the hash function. It will compute the same thing. It will take the first letter of apple, it's A, so it just goes to the first location. It will get the apple and will directly give you. So it doesn't have to go through all the locations. So the problem with that kind of infrastructure is give me another fruit that starts with A. Avocado. Is that a fruit? It's not. Anyway, doesn't matter. Apricot is a fruit. Fine. Apricot is a fruit. Sorry. So yeah, I heard of it. I don't know. Actually, I think I have heard of it. Yeah. So what happens is if you're in the discussion has gone ahead. So now what you want to do is you want to store apricot in your hash table as well. You know that apple is in there. You're storing apricot. Your hash function does the same thing. What it does, it takes the first character of your input. It's nothing but A. It will again go to the first spot, but there's already something in there. It won't overwrite. Obviously, it won't do that. So what it will do?
Go to the next.
What if next letter is spread? B, there is already a banana in the second column. So that thing where you went to store something, but you already found something, that is called a collision. So collision is a problem in hash tables. You have to. So why was the problem arise? Because our hash function was silly, right? It was not a good hash function. You just took a simple hash function that only took that only considered the first character. So that's the reason they say your hash table is as strong as, or your entire thing is as strong as your hash function is. So if you come up with a smarter or clever hash function which reduces collisions, then you have a good chance of storing. So that is why hash table is really, really important. There are many questions that can be solved. But the only problem is there's just too many functions in there in the question. There are just too many things to be done. Just to give you an example, it won't take more than 2 minutes. We were actually solving this problem last night. There was this question where it just passes these kind of variables: 1, 7, 4, 5, 2, 3. Let's just assume this. So the input is this, and what the output should do, what your program should do is, out of all these 5 numbers, it should check how many pairs there are whose difference is 2. And then that number of pairs should be outputted. For example, how many pairs can you find in these 5 numbers whose difference can be 2? 5,3, right? If you again 5,3, 3,5 is the same thing, so you cannot repeat it. 5,3.
7 5.
7 and 5, yeah. 1,3, right? So now your output should be 3. This should be your output. The input of the program is this thing, and the output should be 3. So you have to actually write a program that does this. So we couldn't come up with a solution, but we tried hard coding it, literally using for loops and while loops. But when we actually went ahead and looked at the solution, it was really simple. But the thing is, he used a method of hash table, which I didn't know. So the problem is, if you are aware of all the methods in hash table and how those work, it's really easy. So again, it just gets complex, but I really want to explain the solution, which I will do on Saturday if there's time or you're interested, either of the two. So that, you didn't understand the question? Oh, I just answer simple. And how to find it, like in hash set, like they only give the location directly. So how can you, that is what it does. It takes your input, takes the hashing function, performs something, and it gets the output, and then it directly goes there. So it does not remember the address. But the point is, no matter 10 times you execute the hash function on the input, it will always give you the same location. It won't change. So you can always go to the same location and get and bring in that. Something. Again, sorry for this. So yeah, coming back to thing. Asset, string asset, reset, you understand these things right now. Let's go ahead and see. But what's the difference between list and set interfaces? All the classes of the list and all the classes of set. What's the difference between list and set? Major differences. List accepts duplicates. Set does not accept duplicates. Right? Set does not accept duplicates. That is what it does. Let's try doing that. See, there are 2 Java, but only 1 Java. It does not accept duplicates. Now the question comes about map. Before talking about map, I'll talk about one thing called as generics. Okay. Right. So now our linked hash set, that is nothing but h1, can store any object. Doesn't matter if it's a string, if it's an integer, or if it's a float. Which so it was fine, but until some point, it was actually seen as a vulnerability, because now there's no restriction on what kind of data or what kind of objects your collection can store. It can store anything, right? So, but if by mistake or something, if it was there, no integer should have been allowed, but for some reason you ended up entering or storing some integers, and for that purpose, they came up with something called as generic. Okay, so what you do is you specify what kind of data you should store in the declaration itself. So if I want my hash set, or if I want my linked hash set to store only string, then I explicitly write string in angular bracket, and then I also write strings here. And writing a string on the right side is again optional, not necessary, but this is how you restrict your linked hash set to only store strings. That's the reason when you put this thing, this is never being popped up, because 5 is not a string. So this is how you limit it. Again, you can apply this generics to all the collections, not just this thing. Okay, so now you can only access string. So back in this example also, you can ask ArrayList to only store strings, okay, in the angular bracket. And here for each, you can, instead of writing object, because here you wrote object because you didn't know you can come up with string, integers and all that stuff. But now that you have restricted your array list to only have string, right? You can say string directly. You can just say for each string in array list, keep printing the string. That is what generic says. It allows you to restrict the type of object that you can store in a collection. So fine, we're done with this. Now let's see what map interface does. Same thing. Map interface has 3 classes, just like that. Hash map, linked hash map, and then tree map. Right? Let's write those 3 things. Hash map. But one thing about hash map is it stores data in a different kind of way. It stores data in key value pairs. Okay, something called as key value pair. So you have to give it a key, and then whatever the input you want to store will be your value. So if you want to store the names, then key should be like 1, 2, 3, 4, 5, and then value should be your names. So later on, again, retrieve the values just by passing the keys. Right? It's just how these maps store elements in a key value pair. So you have to specify when you're writing a hash map to store objects, you have to specify during declaration that what type of key are you going to use and what type of value are you going to use. You have to do that. So you have to say that for key I will be using integer, and for value I'm using string. Hash map equal to new hash map. That's what it said, right? It does not accept primary data type. Okay. You start doing that. I don't know if it works or not. See, it does not accept these things. You have to pass. No, that's a bad spelling. So now, you understand why I did this, right? Because hash map stores content and key value pairs. You have to specify what kind of key and what type of value you're using. Now let's just take hash map, and instead of add you have put here. So you use put 1, and then you provide the value. Like hello. Right? Let's try printing this hash map. Hello, map, and word. Now let's try with all the other classes. Same thing. Line hash map. Hello, world map. See, here it's following the insertion order, right? Hello, world, and map. Whatever the order you press, first 3 and then 2. See what it does with. Hello, map word, right? This is how it does. Now, one important question about this thing is, again, you can use it, you can use for theta, all those kind of methods, but can you iterate over a map? How do you iterate over a map? You cannot iterate over a map because you can only iterate over those collections which implement this interface iterable, right? So because you don't see, do you see a map interface here? You don't, so that means it does not implement iterable interface, so you cannot directly use iterator here. So how do you iterate over a map? This was actually a question asked here from here. How do you iterate over a map? You have something called as map set. See how it's done. HM dot let's just say map.entry. So you use for loop for each loop, and then write hm dot. I'll explain you what I'm doing here. For map dot entry. Okay, why cannot you use iterator? Why won't you use iterator over a map? Because the thing is, you have keys and you have values, so they thought it's just difficult to point to the entire record at once. So it's better idea to altogether not implement it and provide a different way. So what have I done here? The thing is, you know how you read for each loop, right? So let's just first read for each loop and see if it makes sense. For each map entry that is of type integer and string, store it in H. Okay, of the entire, for each map entry in the entire entry set, store it in H and get the key, get the value. That is what I'm saying. This hash map dot entry set, this represents the entire hash map itself. Okay, there's nothing but tree map in this case. So it represents the entire set here, and in the entire set, we are taking each entry that looks like in this thing, integer and string, and store it in H for temporary purpose, and get the key from H, and get the value from H. That is how you do it. Okay. Let's see if this actually works. Yep, so right. So map and word. Again, map entry. Remember how it's done. Now, one more thing we have to talk here is, let's go back to the slides and see. That is it. Okay. So what have we seen altogether in this entire time? We've implemented these three classes, right? And the hash set, linked hash set, tree set, and hash map, linked hash map, and tree map. So first of all, let's just giving you kind of summarizing thing. So array list, linked list, vector are nothing but classes on the list interface. And one thing to remember about list interfaces, accepts duplicate. Okay, list accepts duplicate. Set does not accept duplicate. And set again has three classes: hash set, linked hash set, tree set. Tree set implements sorted set also, so you can say tree set element is order elements in ascending order, right? Whereas linked hash set always follows insertion order, where you keep linking each element to each other. Hash set does not really have an order, so it just runs randomly. And queue has two classes: priority queue, array, key queue. We'll try it out how these things work, and then you have another interface called map, which stores elements in key value pairs. And there are a lot of questions about, can you have a null key or can you have a null value? What do you mean by that? Can you have a null key or can you have a null value? Thing is, you can have null values, but you cannot have null key. Like, I think there's only one null key allowed or something like that. But again, there's too much theory in there. So hash map versus hash table. Again, hash table is what exactly hash map does, but the difference is just like array list and vector. Okay, this is not synchronized because it's a part of collection framework, and this is the legacy class hash table. So this is actually synchronized. Let's see if hash table directly replaces that. Hash table. Hash table. Okay, I think these are yep, sorry, T is small. That is your hash table, hash map, both the same things, but the same difference is that one is legacy class and one is actually part of collection framework. So again, you have many differences here, like, you know, this is faster, this is slower because this is synchronized and this is not. Thread safe, yeah, that is what it is. If it's synchronized, then it is a thread safe class. If it's not synchronized, then it is not thread safe, because when you have multi-threading, it can blow up if it's not synchronized. You know, if you have multiple threads and one thread can access hash table, one thread can be, you know, inserting elements and one thread can be removing elements. So you're not exactly filling the hash table. So you need your hash table. If you need your hash table to be synchronized, because that you can deduce, because you initially know that if you're working in you'll know if you're working in multi-threading environment or not, right? If you're working in multi-threading environment, it's a better idea to go with synchronized classes. If you're not, then you'll why just slow the classes, why just slow up the class by using synchronized things. Again, it depends on what exactly you're trying to do with the program. So I've shown you how to, you know, create instances, how to put objects, how to remove objects, and how to iterate over objects, right? For less than set, you can always use iterators. For map, you cannot. Even for queue, you can use. But for less queue and set, you can always use your iterators. For map, you cannot use an iterator. You use entry set. This is how you iterate it. And I really suggest you to go check this website and there's just compare different classes. Do you see there are these versus links? Yeah. See all those links, right? See what the difference between these two are, and all those things, and also practice what queue interface does, you know, the array queue and priority queue, practice those things. Now, other two important things to know these two interfaces, comparable interface and comparator interfaces. This should take a while, so if you guys need a break, you can use the break. It's okay? Awesome. So now the question is, coming back to this, let me just remove that. So I have three objects of student, let's just. So you have a method called collection sort, right? Exactly, that is what I thought. See, what happens is you have three user-defined objects. You have an array list AL, and then you are adding objects to your array list, right? So there will be many cases where you want to sort objects of your collection. You want to sort, you want to sort the contents of your array list. So you can directly, you have a method called sort in the class called collections, which I discussed earlier. This is a utility class collections, and where you have a static method sort, which takes a parameter any collection and it will basically sort the objects of collection. But the problem or the condition here is the object, this sort method will only sort the objects of those collections whose objects are actually sortable. I mean, you should be able to sort those objects. Only those objects it will sort. So if you directly store, if you just have strings, integers, floats, you know how to sort, right? If I give you a give you integers, you know how to sort it. But if I give you complex objects like J4569, my869, or an object that has address, email IDs, numbers, and all those kind of complex objects, how would you sort those things? Based on what? It doesn't know what to do. So sort method will only sort those objects which implement an interface called as comparable. Remember this thing, guys. This is really important. If you understand this thing, it will save a lot of hours for you guys, because this is actually as an interview here and your real interviews as well. So if you concentrate here, it will save you a whole lot of hours, because this is really tricky and as well important. Make sure you, I'll put the effort, but make sure you understand it, right? So first thing you have to remember is the sort method that is present in the collections will sort only the objects that implement the comparable interface. Okay. Now the first question should be, then how can I directly sort strings or integers? How can I directly sort them? Because those, how do you know that those classes or those objects are sortable? The reason is strings and all those wrapper classes, integer, character, all those classes by default in their definition implement comparable interface. They actually implemented those classes, predefined classes. That's the reason you don't have to explicitly add some more code to make it sortable. But whereas our user-defined classes cannot be sorted because they do not implement comparable interface. So let's just make this class implement comparable interface, right? So just write implement comparable. Now once you write this, because it's an interface, you have to implement all of the interfaces method, but there's only one method in comparable interface, which is nothing but compare to method. So now you might understand what this method does. This method provides the logic on what basis it should be compared or sorted. So this thing will provide the logic. So here you can write, let's just say comparable will have objects of type student. Okay. Comparable student. Okay, let's say. Is there a student class somewhere else? I think there is a student class, right? You have already used student class. Yeah, it's just student 5 or something. I don't know, I'm not sure. Yeah. But no, initially it worked, right? First time, yeah, let's just put it that way. Like here. Type student must implement the inherited abstract method. Okay, fine, sorry. The method is gone. Compared to, yeah, I'm sorry. So inside the compare to, you should basically provide the logic of on what basis should I sort the objects of students. So that's how this sort method will understand. When you pass an array list which has student objects, it will sort method will go and look into compare to method, and it will understand, okay, I have to sort the student objects on this basis or on this basis, something like that. So you have to provide that logic. So what you do is you return if you just write conditions. If what do you suppose, for example, you want to sort based on ID. So what you do is if ID is equal to o.id, then return 0. Okay, and else if ID is greater than, I'll explain you what I'm doing here. Let's just return -1. Now let's see if we can sort the object. Right? 4569, 8569, and 8869. The objects are sorted, right? Now, what exactly did we do here? What this compare to method does is, it will, when I pass the entire array list, when I'm passing the entire array list AL to the sort method, so basically it can see all these three things. So what it will do is, I said I want to compare based on ID. So what it will do is, it will take the ID of first object and it will take the ID of second object and compare. If it's equal, it will return 0. I'll tell you what the significance of 0, 1, minus 1 is, but if it's equal, it will return 0. If it's greater than, if this is greater than second ID, it will return 1. And if it's less than that, then it will return minus 1. So what exactly 0, 1, minus 1 means? 0, 1, minus 1 means when you are returning 1, so sort method, who are you returning that 1 to? To sort method, right? So when sort method receives 1, it understands that, okay, because that object is greater than this object, it returned 1, so it will swap those two things because you're doing it in ascending order. It sorts objects based on ascending order, so it will swap. And if it's equal to, if it returns 0, it won't swap. Sort method won't swap these two IDs. It will just put that way. So this sorting is done based upon getting the value 0, a positive number or a negative number. If a negative number is returned, then that means just put it that way. 1, swap it because you wanted ascending order. If you want descending order, you can just say if it's greater than, then return minus 1. If it's less than that, return 1. See, now it's descending order, right? Yeah, it keeps checking that thing. That is how it does. Because now, initially what happened was, if you don't specify, if you don't write this, if you don't make this class implement comparable interface, and if you don't write this compare to method, and if you directly pass the array list which has student objects to the sort method, it won't know on what basis to sort. For example, right now I only have ID. What if I have marks, grades, and all that kind of stuff? There are too many variables to take into consideration, so it doesn't know on which basis should I sort. So basically what you are doing here is, you are providing sort, you are helping sort method by writing this compare to method, by showing sort method a way in which to sort. So you are basically helping this sort method. No, that's the excellent question. That's the problem with comparable interface, because this class need to implement comparable interface. This class has to override this method, right? That is the problem of interface. It's contract. You have, this class has to implement compare to method, so you can only consider one element. So even if you have 10 variables, you can only consider one variable. So that means it only gives you single sorting, right? This is only unit sorting technique. You cannot sort objects based upon multiple orders. So as a developer, you have to decide which one to pick. You cannot say, sometimes I'll do this, sometimes I'll do that. You cannot do that because this class has to implement. There's only one compared to overriding chance. So it's this chance. Either you have to write ID, grades, number, whatever it is, you have to just provide the logic here. Is this making sense? Exactly. So that's the reason we have one more interface called as comparator. Let's see what comparator does. Command. What's that? I'll tell you. So what I'll do is, I'll have a class ID comparator or some random name, and I'll implement another interface, not comparable, but another interface called as comparator. So because this is an interface, I have to override some method. Let's first implement. So this comparator interface will have method compare it. Again, see, it's not compare to, its method is different, compare of comparator interface, right? So now I don't want class student to implement. Instead of comparable, what am I doing here? and say if, let's just make it shorter, S1, S2. If S1 dot ID is equal to S2 dot ID, then return 0, and check S1 dot ID is greater than S2 dot ID, then return -1. Let's just return 1. And return. Okay, guys, my question, see, what was the question that she asked? Initially, if you're using comparable interface, then the condition was whichever class of object you want to sort, that class must implement comparable interface. Is this clear? Now I want to sort objects of class student, right? Initially I'm talking about the comparable interface, right? The requirement was I want to sort the objects of student class. So because I want to sort the objects of this class must implement comparable interface. Okay, if you're using comparable interface, this class should definitely implement. Because we have that restriction that this particular class should only implement comparable, this class should also override compare to method, right? So we can only provide one logic, but with compare to method, but with comparator interface does not say or won't say that class student should only implement comparable interface or comparator. What comparator interface does is, it removes that restriction of class student should implement this interface. This says that you just write any random class and make that class implement comparator interface and provide the logic, and then in sort method you basically pass the instance. What is the class name here? ID comparator, right? So you say ID comparator. Now see what happens. The objects are sorted. So now how is it different? The difference is I only have one variable here, right? For example, let's assume I have marks, right? I have marks here. So now if I want to sort based on marks, then what I'll do is I'll have a same class of this type, and then just change name, write marks comparator, and then provide the same logic. So if I want to sort the object based on marks, I just provide the different class. I'll just say marks comparator. Isn't this a clever way of achieving multiple sorting? So now you don't have restriction that you should pick one variable to sort. Why? The reason is because this is comparator interface, guys. The reason is comparable, which is another interface. The comparable interface says, or the rule of the comparable interface is that this class student should and must implement its interface. So if that is the restriction, then this class should implement the compare to method, right? Because you are implementing an interface, that means you have to implement all its methods also. So you have, if your class student is implementing compare to method, then you have only one chance of providing logic. So you have to either pick ID or you have to pick marks. But comparator interface is cooler than comparable. Why is it cooler than the other one? Because comparator interface does not impose any rules on it. Comparator interface does not say that, hey, because you want to sort student objects, your student class has to implement me. It does not say like that. It says just make any random class implement, provide the logic, but all you have to do is you have to tell sort method which class is logic based on you want to sort, right? You have two compare to logics here. One sort based on ID, one sort based on mark. No, you cannot do that. You can only give one. There is again greedy approach, but you can only have one sorting, one sort down. No, but the thing is, you can always write switch statements or conditions if this matches sort on this, if this matches sort on this, or something like that, right? You have multiple sorting methods. Again, I didn't change the variables, but you also have to change marks. Anyway, because we don't, that is, you understand that thing, right? Any questions about this? Comparable and comparator interface. And collection, this sort method implicitly gives the call to compare to. Okay, so don't worry where am I calling this compare to method or not. And it swaps the value based on these return value. If 0 is returned, then that means it does not make any change. But if a positive and a negative number is returned, it understands, okay, one is less than the other or one is greater than the other. So now so this logic is ascending order, and if you want descending, you can just change negative and positive. You'll figure it out how it all works. Any questions about this? Just a quick review I'll give what we actually studied. See, I have an array list here, and I'm storing certain objects in array list, right? So if I would have just stored strings and numbers, forget SS1, S2, I would have just stored this same, I would have just stored hello, world, Java, something like that. So in order to sort array list now, I can directly write collections.sort. Why? Because the content of array list is just strings, integers, and all those things, right? So those have already implemented comparable interface. And other than that, the logical reason is because it's obvious, right? You don't need extra help to sort integers. When I gave you 5, 3, 7, 8, you can say which is greater and which is lesser. You don't need any extra help from any other class. So that's the reason when your array list has a predefined objects or or string and integer objects that can directly sort. You don't need all these compare to method logic and all the stuff. But the question arises when your array list is storing user-defined objects. So when your array list is storing user-defined objects, it does not know on what basis should I sort. Should I sort based on name? Should I sort based on ID? Should I sort based on marks? Because what you're just saying is, you're just passing S1 and S2 and you're just asking it to sort. So it does not know what to consider. So what you do is, you have to make sure that your class, whichever class's object you want to sort, that class must implement comparable interface if you want comparable interface. But what's the problem with comparable interface? The problem with comparable interface is that class should implement the interface and the method also, right? Obviously, because it implements interface, it should implement the method. So you can only provide one logic. So there's only single sorting there. But what happens with comparator interface? Comparator interface says this class student need not implement. You can write any random class and implement this interface and provide your own comparator. So now I can have 10 classes that implement 10 comparator interface. So now I have 10 compare methods. So I can provide 10 different sorting logic. But all I have to do is I just have to inform sort that, hey, I want to sort the objects of array list based on this class. Whatever, if it's marks, IDs, grades, doesn't matter. You can provide through runtime. So it supports multiple sorting. That is what it does. Any questions about this? Yep, a lot. Comparable interface, comparator, it's just Hadoop and all that kind of stuff. You extensively use this thing because you store things and you sort. You keep sorting those things. It's extensively used. It's not just used, it's used so much. That's the reason I said you might want to understand it, because eventually you have to study this other topic. Because multi-threading, I don't know so, but this thing is really important. Comparable, comparator interfaces, and array list, hash map, hash set. Again, all I showed you was add, all, put, get, and those simple methods, but there are just so many methods. So if you're interested, I'm not saying all those methods are required, but if you're interested, you can go ahead and check. There are just too many methods to learn about.
Hello?
Any questions? Yeah.
Can you go to the top, like to the comparable implementation of that comparable?
Comparable, I've actually removed it.
Okay, so you did with the single object. So I thought of asking that. I understood what you said. That is, the class should implement the method, and the class not like comparator where we can do with any classes. But
Yeah.
I just want to understand the logic, how you actually, I mean, you did with a single object, like here you are comparing with two classes.
Oh, okay, okay. Very good observation. Very good observation. I almost forgot to say that. Very good observation. What she's saying is, in this method, I have two objects, S1, S2, S1, S2. So I'm explicitly comparing ID of S1 object with a different object, right? But again, what this S1, S2 means is just two objects. Don't just confuse with these S1 and S2. It just means that I'm taking two student objects and then I'm comparing it. But prior to this, when we used comparable interface, there was in compared to let's just do that. Instance comparable. Wow, ID is awesome. Add an implemented method. Yeah. So here you see there's only one student object, right? But here I had two objects, so I was kind of comparing. But her question, I think, if I understood correctly, was there's only one object here. So based on where's the other object that is sorting it, right? That was your question, right?
Yes.
Okay. The thing is, even though the only difference is you explicitly see here two objects, and here you don't. But where the other object is, it always considers this instance. You know what this keyword is, right? So it will take one instance of the current object and the other object that is being passed to it. That's the reason I wrote return, or I said if ID is equal to o.id, return 0. That's the reason why we said that. So this ID is nothing but current instance of ID, and then ID is this is the second ID that is being passed. So what it does is it will keep 4569 and it will pass 8869 to it, and it will pass 8569 to it. Again, both the objects are being passed. It just doesn't. It's not obvious through that method definition. It always uses one current instance and one instance that is being passed. Good question, actually. Yeah. Any other questions about this? Go ahead and remove this. You need to deliver the data. You want to know that the data is actually delivered. The exact opposite is UDP. UDP, you don't care if the data is received. I mean, you don't care as in it's not really important that the data has been delivered to it. One good example is online streaming services are actually UDP. They're not TCP. I mean, yeah, we want them to be TCP, but they don't care if everything is being served to us. YouTube works on UDP protocol. It's not TCP. Any online media streaming services, you see what happens is when you're streaming a movie, the screen might, the video file, the web page might freeze for like 5 or 10 seconds, and then all of a sudden you skip that part and directly your movie will be resumed after that 10 seconds, right? So that means you have lost the data packet in between those 10 seconds, and you're, as a client and as server of some YouTube server, they don't care that you have lost. They don't retransmit those packets, and your movie doesn't actually wait until the data is received. If it's gone, it's gone. It just keeps on continuing. So if you don't care that packet delivery is important, you use UDP. And that's enough for this thing. What exactly, we know what socket programming is, but what exactly socket means? Socket is nothing but, just imagine as a plug point where two programs connect, right? That is what the socket programming is. And you have a class called big integer class, big decimal, and all the other classes. So as the name itself indicates, when you want to deal with bigger integers, right? So you cannot use the actual data types or the actual wrapper classes. For example, you're writing an expensive mathematical application and you have to store the factorial of 100. You know how many digits the factorial of 100 has? More than 150, 157 or 158 digits. So there's no way you can store 158 digits in integer, float, double. There's no data type that can store 158 digits. So in that case, it's a good example to use a big integer. And the way, if you want to know how you actually declare it, just like the old school thing. Let's just go here. Here. Yeah. So how do you write same thing? Big integer are equal to new big integer. So it's an object. Yeah, that is what you do. So no matter how long that number is, it still kind of holds that data, and you play around with that kind of data. So if you know what when to use, right? If you're dealing with larger numbers, go with big integers. Yep. And you have generic class. What generic class does is, see, there's actually a code. Let me just copy this out. See, what generic does is, for example, you see this class. In this class, you have an object, and if you don't know what kind of object, if you don't know if it's a string or if it's an integer or something, instead you can just replace it by t. You can just replace it by t, and when you are actually initializing, then you can specify t. Here it says mygen integer, so that means now t is nothing but integer object. So if you're not sure it should be an integer or float or something, then it's a good idea to just write t here, and then while instantiating the object in the Angular braces, you've seen generics in collections too, right? You say that integer. So wherever in the class you see t, all this t will be replaced by integer. That's generic 3. So what you're doing, you're writing a class where you have some variable, okay? You're having some variable and you have a constructor also, you have a method that returns something. But the only thing that is different here is you're not specifying which type of object. You're not saying is it an int, is it a string, or whatever it is. Yeah. So what you do is, instead of specifying the name, what you can do is you can specify the class itself as t, so that you're saying this class is a generic data type, and then write the variable you would normally use, integer or something, and then during the runtime when you're actually instantiating an object, then pass integer. So all these t will be replaced by integer, and then you can directly add 2, and then you can get 2. If you replace it with string, you can write string. That is how it goes. Yep. So now assertion. Again, assertion is actually, assert is a keyword. Why does it? It has two expressions, expression 1 and expression 2. What happens is, it will I think there's a program here. Yeah. So what assert does is, see, this is expression 1. This value is greater than or equal to 18 is expression 1. So what happens is, when you're writing assert, your assert value greater than or equal to 18, your program assumes that the value is greater than or equal to 18. If the value is not greater than or equal to 18, it will print this thing, not valid. So it breaks your program. That is it. It's not a if else stuff, it actually breaks down your program. Right? It is actually to raise an error explicitly in your program. Again, these things are by, let me just show you. Write the program. See another file for this also. So, you're just asking user to enter some age and then input the value, and you're writing assert value is greater than or equal to 18. So it assumes that your value is greater than 18. If it's not, then it breaks down. So let's try and execute. This won't work. Let's try and give some value. Yep, it won't work. Because the thing is, by default, assertion, because see, it's risky. It breaks down your program, right? So by default, these things are disabled in your IDEs or whatever it is. Even if you're writing program through command prompt, you have to explicitly provide the command that enable assertions and all that thing. So in IDE, I think, I'm not sure, but let's just try. Right click. Argument. This is the one. Yeah, this is nothing but runtime argument. So when you're writing in command from Java class name, right? So this next to that, you're writing these commands. Assume it like that. If you're confused, in the first class, if you remember, we used to write something like this, right? Java demo. So to enable assertions, you should write -EA. That means enable assertion. So that is what you do here. Enable assertion, apply, and run. Let's see if it works now. Yeah. It raised an error, right? Again, for the guys who messed it, just go to your class, right click, and go to run as, and go to run configurations in arguments. Just do that, hit apply, and then hit run. That is what you do. Nested classes, which is really interesting, but I'll just tell you briefly what nested classes are. What are nested loops? Loop inside another loop. You have nested if loops, nested that loops, and all that kind of thing. And nested classes is the same thing. You have a class outer, for example. You have an outer class, and then inside this outer class, you'll write an inner class. Not just declare it, but you'll actually write the entire class in here. Now, what's the point of doing this? Again, inner classes does not give you any extra functionality, or it does not have any extra, features or something. The only thing is for code readability and things like that. What kind of code readability that means? If there is a class that will be used only once by this class. So instead of writing this class in a separate file and just confusing some other readers that why would we need that class, just make it an inner class so that whoever is reading your code will understand, okay, this class is, because this is an inner class, it must be used only once, that too by this class. So that's just code readability and stuff like that. So what do you see all these 4 different weird names? The thing is, you have 2 types of nested classes for, okay? One are static nested class, and the others are non-static nested class. What do you mean by static nested class and non-static nested class? Static nested classes are the classes, we have that in your classes, right? So these classes are actually declared with the keyword static. And the non-static nested classes are not declared as static. Which one do you prefer? They usually prefer non-static nested class. Why? Because if you write a static nested class, then that means this class cannot access members of this class. Okay. See, before even writing static class, I'll tell you the feature of an inner class, just a normal inner class. When you write a nested class of this kind, what happens is this inner class can access the code of outer class also. If there are any variables in here, this class can, if you have a method display here, that can display variables of the outer class, so it can access. But if you declare this class as static, you cannot access these things, because you know that error, the famous error in this, if you directly compile through command prompt and try doing that, access something from static context, you get non-static reference cannot be made from static context or something like that. That means if this is a static reference, so from static reference you can only call static things, static methods, static objects. So you can still access outer classes members, but the condition is they itself should be static. So that's the reason they don't usually go with static unless it is a requirement for you. You don't go with it. Usually prefer non-static nested classes. And another name for non-static nested class is inner classes. This is one confusion. When people usually refer inner classes, we by default assume that they're meaning nested classes. No, nested classes is the entire thing. In nested classes, we have static nested classes, non-static nested classes, but we don't usually consider static nested classes. We go with non-static nested classes. And there's one more method, one more name for this, called as inner classes. So when someone is saying inner class, they're referring to that. And it uses something just a text. So apart from static, non-static, you have two more classes called as local class and anonymous class. You have anonymous classes. Basically, there are 4 types of nested classes: 1, 2, and 3, 4. Local classes. What's the difference between local class and these classes? Local class are actually written inside a method. For example, in the class outer, you have a method something like void calculate. Okay, so inside calculate, you'll write a class. Again, is this really necessary? I mean, is there a way around? Yes, there is. I mean, you think things are getting complex here, right? But it's just to improve code readability, right? So if someone else reads the code, he understands, okay, so this class inner, I understand that this class is basically used for only this method. No other method is using this class. You can understand this type of stuff. But if I would have placed class inner in a separate file, you wouldn't have known that. So just to improve readability purposes, so you do this kind of stuff. So this is local class, which is declared inside a method. So it can only access things inside the method. It cannot go outside of this class. Now you have one more class called as anonymous class. Do anyone of you watch Game of Thrones here? No? Seriously? Come on, man. Seriously? Wow. Anyways, there's a reference in there. Girl has no name. I don't know if I'm going to relate or not, but anonymous class is the same thing. A class does not have a name. A class with no name is called as anonymous class. So how would you write it? No, the way you declare it is different. For example, if you have an anonymous class, what you will do is something like this. You have you write something like outer x equal to new outer, and then here before you close this, what you will do is you write and then you close it. That is how you do it. So you basically, what do you mean by you are extending this class's features. So in here you can access the object variables of this class also. Just another way of representation, but I don't think we'll use these classes. But good idea to know all this, right? 4 nested classes: static nested, non-static nested, local and anonymous class. No, I'm just using it for example purposes. It's easy to say outer class and inner class, and the name itself is outer. You can write any other thing, class X, class Y. Yeah, you have nested inner classes. Right, you have nested, static, non-static, inside non-static. You can write all the 3 different types, right? So you have 4 types of nested classes. And when they are specifically saying in your classes, they only mean these. Regular expression, we have already seen regular expression, right? Regular expression, clonable interface. Clonable is an interface. What it does is basically if you have, if you use, where did it go? Yeah. You have a class demo, and if you want copies of this class's objects to be made, right? So you, for example, in the main method, I have something like demo d equal to new demo or something like that. And if I want to make copies of these, I want to make 3 or 4 copies. So I want to, whenever I want to clone an object, the class itself should implement clonable interface. So only then I can clone its object. Right? You know, you understand the difference. If you want to clone any object, then the class itself should implement the clonable interface. And if you don't do that and do something else, then this exception will be a clone or polar or all that kind of thing. This is the method basically you call on the object to clone. Right, I think this is an example. Yeah, that is what you're doing here, right? You have x1 object, right? This clone class in the last slide actually implemented the clonable interface. So you have x1 and x2, and x2 is equal to x1.getClone. So you're basically getting the clone of x1 and putting it on the x2. So now you have 2 copies of x1 and x2. Serializable and deserializable is one another thing. What exactly is serializing and deserializing are 2 processes. Serializing is nothing but it's a process that converts an object into a byte. It represents an object into byte so that you can write that object, state into, you know, database file or somewhere else, or if you even want to send it over the internet, everything is goes into bytes, right? So if you did something, for example, if you have an object, you want to save the state of the particular object. Like you're writing a simple bank application, and then one particular object has a balance, account number, and all that kind of stuff. So if you want to have a snapshot of that particular, what the balance is and all that kind of things. If you want to store a particular state of an object so that you can later on, you know, access that. So you convert that object into bytes so that you can write those bytes to a file. So that process is called as serializing, and the other process, converting something that is already in bytes to an object, is called as deserialization. So you have 2 methods, read object and write object. Write object converts the object into bytes, and read object convert the bytes and back to an object. I think there is an example. Yeah, you have this thing. Object is being converted into string of bytes is nothing but serialization. And then once you have string of bytes, you can basically write it to a file, write to a DB, write to memory. And again, this entire reverse process is deserialization. Serializable and deserializable. Do you want me to execute this program once and see what happens? You guys can copy this and run. But one thing you want to do is you have to actually store at a particular location. Oh, we didn't actually see what file IO, right? I'll show that again. Simple thing. There's no file IO here. Anyways. File IO, I think so. Oh, okay, I think this is the last PPT itself. No, oh. Oh, that's in JDBC. Yeah. IO slide. Yeah. Anyways, you can copy and check those. Volatile modifier. What this modifier tells is basically when you're using multi-threading environment and you don't want your variable to be messed up. The multi-threading, you declare those variables as volatile. So it basically, what it does, it writes to the field should always be synchronously flushed to memory, and that reads of the field should always read from memory, reads and writes to volatile. That's the atomic. This is what it says, right? The read and write should be done in one operation. It cannot be intermediate, so that in multi-threading it's just safe to have volatile variables and things. Not really important, just another keyword. And this is what reflection API is. It's actually cool, reflection API, what it does. If you try and, I think you know what Oracle Java tutorials are, right? The original documentation for Java. Go look what it tells about reflection API. It says something that it's only for professional developers, and if you cannot want, don't mess with this, and something just scary there. But what basically it does is it will inspect your code at the runtime itself. So what happens is there is a class and there are some private members of it. So from another class, can you access those private members? You cannot, right? That's the point. You have a class demo. In the demo, you have some private members, okay? And then I'm writing a class car. So in this car, can I access these private members of class demo? I cannot, but through reflection API, I can actually do that. So that is how powerful reflection API is. It has predefined methods that kind of mess with the standard rules of Java. So that might be one reason why they don't know how to mess with. Anyways, basically, the testing purposes, they might use some of the methods to to know what kind of methods the class has. If you want to know it during runtime, you can call a method on a particular object, and it will tell you what all methods you have in a particular class and things like that. So yeah, these was all the miscellaneous topics. Let's go back to the IO thing and let's see. It was in 6 slides. Yeah. So again, IO, you already know that there is this console way is not the only way to give input and get output from Java programs, right? This is not the only way. Using this console is not the only way to write input and get output from the program. There's another way. You also deal with files. You can take input from files. You can write output to files, which is what you usually do. And you also have databases where you write stuff into database and you retrieve from database, and then you also have some. You will do that over network, right? You send something over network and get something in written from network. But let's see how data is written into file and how data is copied from file. There are two ways of doing it, right? There's two ways of doing it. One is byte based and another is character based. Okay, so I'll just right away show you these classes. Don't get scared, this is just too much. All the classes that you have in IO, but you don't usually require all these things. But what basically you see, these two columns are byte based and these two columns are character based. So what byte based does, the same thing is done by character based. So let's just ignore these two columns for a while and I'll tell you about these two things for a minute, okay? So in byte based, you have input and output. So these are the classes that you require for input and these are the classes that you use for output. So you have input stream reader, these are the basic classes. No matter what you're taking input, you can use input stream class. And if you're doing output stream, you can write output. Now if you have specific things, like if you're reading input from an array, then byte array. If you're reading from file, then it's a good idea to use file input stream. And if you're using a pipe, it's nothing like it's again used in socket programming. You have pipes where the programs communicate each other, and you can use these kind of various scenarios. You have various classes is what I would mean, right? These are the input classes and these are the output classes. Now, how is it different from these things? Again, you have the input classes, again you have output classes. But the only difference is, you see the name here, these are byte based, these are character based. The difference is, this takes input byte by byte. It takes 1 byte, that is nothing but 8 bits. It takes 1 byte and another byte, and it grabs 1 byte by byte. But with here, it grabs each character. So the problem with byte-based is, so now the question is, when would you use byte-based and when would you use character-based? If you know that your data is going to be text or in characters, it's a good idea to go ahead with character. If you're not sure what your data is, good idea to go with byte-based. What happens is if you're reading, if you know that your data is character and if you use byte-based, then in Java character is 2 bytes long, right? So what it takes, it will read 1 byte. That means half of character and half of another character. There's no problem in that. But if the program breaks down somewhere in the middle, it's a good chance of messing up your text file, right? So in that case, it's a good idea to know what class is good for what scenario. So again, it's so easy. Let's just use one of these. Let's either use byte-based or character-based classes to take input and write output to a file. Okay, and you can try the other one. I have both the examples in the slides, and you guys have the slides, right? So you can run the other one. I'll show you character string. Okay, awesome. Let's do this one. Copy here. Okay. Yeah. So the reason it was it's a different block, so it doesn't know what in and out is. So I declared these variables out of the try block and then used it. Anyways, what this program does is we have 2 files. Okay, we have 2 files. One is an input file and one is an output file. Assume it. So what I want to do is I want I think this program actually copies first file and writes the data into next file. That is what it does. Okay. So what you basically do is you create an object just like you instance it in any other class. You write file reader in equal to new file reader, and in this you provide the path of the input file. Okay. So now in is always pointing to your input file, and then you write the same thing, file writer out equal to new file writer. So there are no 2 pointers, in and out, which is pointing to input file and output file. Basically what you're doing here is you're taking a character and using the pointer in, that's nothing but wherever your input file is, keep reading the characters and keep putting it in C. Do that until you receive -1. When you receive -1, when there's nothing else to read at the end of the file, this means keep reading, keep putting each character, because this is character based, right? This is character based. So keep reading each character and put it in C, and then using the output pointer, wherever output file is there, simultaneously keep writing that character. So you're copying one character from input file, putting it into the output file. That is what you're doing. Finally, this is nothing but exceptional handling, right? You're just making sure that the pointers that you open to input output file are being closed. So again, you can try it out. Anyways, let's go ahead and run this program. Let's see. Stop. That you have something called as tokens. If you're looking for a specific word, like this word you have to stop, then you have to pass that word using some method called as token, so that it will keep checking for that method, and once that word comes in or that character comes in, it stops. That is what it does. This is called tokenizing or something. Yeah, let's put an input file at the location. Let's do one thing. File and yeah. input, and then just copy this program here, right? Now what I'll do is I'll take this location and I'll put it here. You understand what I did here? Yeah. Basically just taking this location and then putting it here. And because I told you Java does not understand single slashes, so you have to give an extra slash and then write input. The file name is input itself, but yeah, input.txt. That is what you want to do. And then make the output file here. So you are saying yeah, you need not create an output file. It will eventually create a file for yourself. So do you see an output file here? You don't, right? So let's go ahead and run the program. I think it's done. Yeah, you see an output file here. It has been copied. That is how it's done. Same thing, if you want, these are attacker-based classes. If you want to use byte-based classes, instead of reader, you use file stream reader, file stream writer, buffer stream, buffer output, all this kind of thing. That is how basically you do stuff here. Any questions? So I think we are done with everything. Let me just pull up. Can you guys please put in your email ID to the chat box? And about the data structures class, I'm sure if we're going to have data structures class on Saturday, 8 a.m. Okay, 8 a.m. Okay. Let me just think about it. Yeah, I'll probably send out an email very soon. And oh yeah, basics about it, not too much. He just asked me to explain few commands about your name.